Good afternoon, everybody. My name is Matteo Ambrosetti from Day One. And today I'm here to introduce you to this award. We call it the Catch Award, where Catch stands for Creative Applications in Thermal Capture and Harvesting, as you can see from this slide. So the agenda for today is to first introduce you to the Heat2Battery project, and then we will move to a quick technology overview. This project has recently started, so it's still an ongoing research. And then we'll move into the Catch Award itself, and we'll give you a brief introduction of how it works, the rules, and what you need to do, the prices, the timeline, these kind of things. And we'll end with an example walkthrough and a Q&A session. So first of all, the Heat2Battery project. The Heat2Battery project is a project where we are trying to develop a new kind of battery. And this battery, it's an all-solid-state thermal battery that can both harvest and store waste heat and convert it into electricity. And the idea is to basically integrate heat harvesting system with energy storage system in a single device that works at different temperatures, but without a temperature gradient. So if any of you have ever heard about the thermoelectrics, this is a technology that uses difference of a temperature difference to generate electricity. Whereas in this technology, there is not such kind of requirement. How we are planning to do this? So we want to turn the heat, specifically the waste heat, into power. And there are a couple of very important steps in this operation, in the operation of the battery, where as for any other battery system, you have waste heat that drives the intercalation of hydrogen ions, and this is the charging step. And you have discharging, the discharging step that happens at room temperature, where this energy is basically released. And the operational window is between the ambient temperature up to 300 degrees. And this depends a lot on the materials that we are going to use. Why we are going to make it? We are going to make it because every degree counts. And we want to convert waste heat into valuable electricity, increase and reduce CO2 emission, and basically support the green transition of Europe. So now I have a question for the participants. So feel free to just speak out loud and take a guess on one of the 5 boxes below. How much waste heat do you think Germany? I mean, we are in Munich. That's why I took Germany as an example. But how much waste heat do you think Germany produces every year? Feel free to unmute yourself and take your guess.
Well, I guess it's a trick question. I would maybe go for the terawatt.
Terawatt, okay.
I would go to gigawatt hour.
Gigawatt. I cannot see you and your name. Can you say your at least your name?
Daniele Trucchi. Daniele Trucchi.
Daniele Trucchi. It's voting for gigawatt hour.
Yeah.
Okay. And who voted for terawatt hour?
It's me, Pallab.
Okay. Thank you. So the correct answer is terawatt, and in this specific case, 254 terawatt hour, which is basically the energy that you can use to charge 150 billion iPhones multiplied by 254, because 1 terawatt, it's the energy needed to charge 150 billion iPhones. which is...
Do I get a prize now?
Yeah, not yet, but it was a good starting point. It's the right spirit. So the waste energy produced by Germany is enough to charge 36 trillion iPhones, which is this number here, that I've never seen in my life before. But it's a really high potential, and that's why we have decided to make this competition, because this waste heat is coming from different sources, and we need your help to find the right application. So who is working on this project? It's a cross-functional team. So we have researchers that are designing and testing new materials. We have engineers who are developing the battery and the prototype. And we also have product and innovation, which is the one where basically our role is to translate this technology into a market-ready solution. Where from factories to city. So these are a bunch of applications or of places where we see a potential waste heat. I'm not gonna list all of them, but what I want is for you to imagine a world where there is no waste heat or no heat that goes wasted. And now we'll give the floor to Nabi, who is one of the scientists working on this technology, to give you a brief technological overview. The floor is yours.
Right, thank you. Hi, everyone. My name is Nabi. I am one of the researchers who is working on this project, and I will briefly explain more technical details of this project so that you have a better idea how it could be used, some more concrete numbers. So yes, just to reiterate what the device is. So this device consists as a normal battery or electrochemical cell. It consists of two electrodes, which are separated by an electrolyte. And these two electrodes are designed in a very specific way. They are designed so that the ion flow between them depends on the temperature. The direction of the ion flow depends on the temperature. So at some temperatures, you have an ion flow from the electrode 1 to electrode 2, and you have the ion flow from electrode 2 to electrode 1 at some other temperatures. This basically allows us to harvest waste heat to drive the charge flow depending on the temperature. So this device can be operated in a temperature cycle between low and high temperature, more specifically between room temperature and any temperature up to 300 degrees C. So this higher temperature is a more flexible limit. This depends on the application. This depends on the materials that are used in this device. So this can be tuned depending on the circumstances. So this change in the ion flow allows us to generate electrical energy depending on the temperature. So when the temperature changes, there is a potential difference build up. We can extract voltages up to 100 or 500 millivolts. So from here, there are two possible applications. So this energy can be stored, and just to give an example of the number so that you can later have a more detailed application case. This could be stored with a density between 0.5 and 50 watt-hour per kilogram. Or instead of storing, this energy can be harvested. So the whole device is then used as a thermoelectric generator. And without the heat recuperation, you would expect around 10-15% absolute efficiency per cycle. Yes, and the final number, which is also very important for your application, is the lifetime of the device, how many cycles it can survive. So this is still quite early development. So you could expect the cycle life around 500 up to 1,000 cycles in a real world use for this device. Yep.
Thank you, Nabi. Okay, let's go back to the Catch Award. So at this link that you can see on the screen, you can find a bit more details about the competition. I mean, if you're here listening today, you've probably already used this, but for whoever sees this next, this is the link to use. Let's start from the basic concept of this composition. What we want is to give you the technology and get from you an idea about how to use this technology. And the competition is open to anybody that it works at university, so students, researchers, PhD, even professors. And we want you to develop new ideas for, like, to help us understand where and how to use this technology. So your mission is to think beyond the lab, think beyond the numbers, and look for a real world impact, combining science, creativity, and strategy, and transform waste heat into something which is valuable. So from both an economical point of view, but also a societal point of view. So you have to connect innovation with feasibility, because there should be numbers that are supporting your idea, and impact. So we want to see how your idea has an impact on the society. On the technical side, I've already said the first bullet point. You can submit as your proposal as an individual or as a team. You should use the official proposal template that will be shared after this meeting to who has registered to the competition. So no other forms are accepted, and we set a submission deadline to the 1st of March of next year. So there is still quite a lot of time to work on it. On the evaluation side, as you probably know, the top proposal will win €1,000, and the top 3 proposals will get a support from us to push forward this idea, some kind of project acceleration. The total number of points that you can get, it's 100 plus 10 bonus points, and we will also give a certificate, like participation certificates, if you reach a minimum of at least 70 points. And to be eligible for it, you must score at least 60% in each category. And below you can see the categories that will be used to evaluate the proposal, and you will find the same categories within the proposal template. So you have innovation and originality, pragmatic feasibility, data research and estimation quality, the clarity of your presentation, of your proposal and its presentation, and in general, critical thinking and foresight. So these are the key pillars for you to write your proposal. And there will be a template, as I've already said. I want to stress this. There is a template, and you should follow the template. Now we can go into an example walkthrough, and specifically, I think it could be helpful for you to understand better what we expect to get. So first step is problem and opportunity. It's very important to state what is the main problem, so where and how this waste heat is generated, so where heat is currently wasted. And together with this, it's important to identify a high value opportunity. So it should make sense to convert into electricity the heat. And this should be also simple. So it should be an elevator pitch. So very few statements, straight to the points. And here there is an example. So for example, you can focus on a data center that are losing a certain amount of heat into the environment. And this, by turning this wasted heat into energy, you will have a certain type of impact that should be defined later on. But now it's the time to set the problem and the opportunity that you see. You also have to specify the industry. So be as specific as you can and try to narrow down to a specific process or a facility type. So the more specific you are, the better. And it's important also to understand that you show in the proposal your understanding of the process where the waste heat is generated. So, for example, are we talking about a batch processing or a continuous processing? Which are the temperatures involved in those processes? Are they constant? Are they changing over time? These kind of things. And it's also very important to mention the type of customer. Is it a small enterprise, a multinational? This is fundamental. So again, to stick to the data center example, here we have a couple of numbers. So the mid-sized facilities, and it's a continuous process. So we can predict the waste heat stream. Yeah. And then still on this topic, it's important for you to be as specific as you can, as I said before. So here, for example, we have a list of all the data centers that are present up to date in the world. And then you can zoom in and look at Europe and see how they are distributed. Again, we are in Germany, so you can focus more on Germany and on the ones in Munich and select the ones you believe are important and could be interested in this kind of technology, could be interested in implementing this kind of technology, and why they could be interested in this. The pain point. So why this waste heat matters? Is it about cost? Is it about efficiency? Is it about CO2 emissions that would cause penalties that again would cost money? And to explain this, you need to back your idea with data. So try to take as many data as possible in the proposal and try to visualize them somehow, or to comment the data, to like explain at a deep level what the data are telling us, and obviously who feels this problem the most. Again, another example, here we have like 40% of the data center's electricity that is lost as low grade heat by cooling system, which represent wasted energy, but also operational costs. And there is a number here, 1 million per year. And this is important because this gives us an idea of what is the market that we are going after. So this is also, as you can see, it's not just a technical, specifically this first part is not technical at all. It's specific on the market, it's specific on the business. So try to get numbers and to find references and mention those references. This is very important. And again, this is a standard when you make a business case. You have the problem and you also have an opportunity. And it's it's important to, as I said before, provide references and explain why our technology is the right solution. So you should also consider other technologies that are already on the market and what is the difference between this technology and other technologies, and why this would make a better fit. As for gaps and key questions, this is the last part of this first section, and is you have to take this as, what if in front of you you have someone from a data center, if we keep the data center use case. What if this person is in front of you? Which kind of questions would you ask to this person? Which kind of data do you think you are missing? What are the assumptions you are making and you need validation on? So this is a very important step in the proposal. It's a very important part, because it will help us in following up, especially not just with the winner, but with also the top three proposals. We will use these questions as the ground for a discussion to engage with potential end users. And now we can move into, let's say, the more technical part of this, which is the detailed description of the application. And here it's important to be as pragmatic as you can, and also technical if that's needed. So you should ask yourself questions like, what heat source will be used? Where is this heat coming from? And then what will I use the electricity that I recover, or the power that I generate for? So what is the end use of this energy? And in this part, you could be high level, but it's important to make clear from where you want to use this energy. And then we go a level deeper. So where will you put this technology in the system you are considering? So we are in a data center again. Which part of the data center we wanna deal with, we will need to deal with, and how is the electricity delivered and used after it is stored? So a diagram, it's a good way to showcase this. And here at the bottom, you can read an example. So the battery connects via a compact heat exchanger downstream of the chillers. It will charge passively, and will discharge through DC circuits into lighting or UPS systems. One of the most critical parts of the proposal is the operational cycle. So you should describe a typical day of your system once integrated into the environment. So when is the heat absorbed, for example? And this connects with the previous parts, the part that we described before. So you need to know how the facility, the application you are trying to work with, how it works. So how the process works when it is generating heat. Is it a batch? Is it continuous? So this connects with this part. And also on the other side, when is the electricity that is stored during the heat cycle, when is this electricity released? And also what triggers these cycles? Is it a sensor, or is it scheduled because the process is fixed? So you have 12 hours heating cycles of your pipe, and then you have a 12 hours cooling cycle, so it's scheduled. All these kind of things would need to be explained in detail. And then now it's the time in the proposal to do some kind of back of envelope calculation. So if you find the data, and I hope you will, and it's important to do some kind of engineering and give the proper dimensions of the battery. So the volume, the mass, what is the output per cycle. And it's okay if you do assumptions. The important thing is that you state those assumptions clearly. So if something is not available, so if you don't find data online, you can make assumptions, but those assumptions need to be clear. And if you find data, you have to reference to those data, so it's possible to check them. And again, as in the previous section, there is a dedicated section to gaps and key questions. And this is also very important because those are the questions that we will ask to the end user. So what data are you lacking? What kind of business information would you like to ask to a company? And which are the risks that you see in your proposal that would need some kind of validation. And with this, yeah, we have a quick recap this slide where I'm summarizing all the steps that have been discussed before. There is another very interesting source that I would recommend you to check. This is a database or data set that has been developed as part of another project, EU-funded project, where you can see the distribution across Europe and divided by different sectors and amount of heat. And you can use this as a reference to find possible use cases. This is kind of a hint we are giving to the participants. Yeah, this is just an example. In Munich, there is a paper and printing facility that is wasting a certain amount of heat. There is a refinery, and there is also an iron and steel industry that is wasting heat. The numbers are all in the data set. And with this, I will stop my introduction to the Catch Award. And now we open the question and answer session. So feel free to ask anything. There are no stupid questions, just easy answers, I hope.
Hi, Matteo.
Hi.
Thank you so much for the nice presentation. I have about 1.5 questions there. So this is just about doing the proposal. I mean, I get it with the right numbers and everything, but you don't expect sort of a prototype or something?
No, absolutely not. No prototype. I think that if the proposal, like the winning proposal, and I would say the top three proposals, will try to help them to become something more concrete in the following years. So this is just a proposal. It's like if you were writing your pitch for a project.
Right. Okay.
What about the other half question?
Well, the other half is slightly bit simple. Do we get a copy of the presentation after this is done?
Yeah,
Okay,
absolutely.
thanks. Okay. Okay. Thank you.
Okay, they are telling me that we will upload this on the website, basically.
Oh, that's even nicer. Yeah.
Yeah.
Okay.
So on the catch, yeah. Once you register, you will also be able to get this.
Thanks.
Any other question? We'll give the 10 seconds. And then...
Oh, sorry. Could I jump in again? Sorry.
Yeah, absolutely, absolutely. Feel free.
Sorry, but okay. Let's say we put in a proposal, right? 1st of March, and then a team member moves.
What do you mean with moves?
I mean, let's say a team puts in a proposal from TUM, right? And then let's say, I don't know, 2 months later they move. What about then?
I mean, if you write a proposal as a team and your proposal wins, then it's up to you to decide how to split the price, I would say. And
Okay.
if it's about how to continue in, let's say, in the engagement and the development of the proposal in the coming months and years, ideally, if the person who left was like a fundamental part of your team, and you cannot continue without that person, I mean, it would be up to you and up to your intellectual honesty to say, okay, no, we don't think we can continue with the project without this person. But I would recommend, I mean, yeah, this is all from.
Okay, thank you.
Okay, I think that if there are no more questions, we can close the meeting. So just to wrap up, thanks everybody for joining. We will upload this, I think, on YouTube and also on the Heat2Battery website in the coming days, and also we will also share the template that you would need to use to submit your proposal in the coming days for the people who have registered to this competition. And with this, I thank you again, and we wait for all your proposals. Thank you.
Yeah, thank you.
Bye-bye.